In this module, we're going to talk about troubleshooting a few common backup and restore problems. And this module isn't for the basics of database backups. I'm going to assume that you're already familiar with things like full versus simple recovery model, when you use each of those, the difference between a full and a differential and a transaction log backup, which ones you're going to need at the time that you do a restore. It's funny, as we all get into database administration, there's no formal school. We end up just kind of falling into this kind of thing. So it's normal to skip some pieces of that. That's cool. Just if you don't know these things, those are the kinds of things you can go research later in terms of books online. But what I am going to focus on here is what you do when there's a log file that's gone missing, how you recover after an oops delete. This is the kind of thing that looks really easy when I show you this RPO and RTO chart. Well, then I'll just restore from a backup, and it's not as easy as it looks, and I'll show you why. And then what you do when your backups are going slow and you need to make them go faster. In order to tell this story, I'm going to use two DBAs. I'm one database administrator and Penny's another database administrator on my team. And you're going to see me from time to time, me doing one thing and Penny doing another, like running interference because some of these tasks are going to suck. It's my job to be the quote-unquote production DBA. I don't deal with people very well. My job is to go through and bang on all kinds of servers and change things. Penny is my senior DBA. She's going to bounce. I'm going to bounce ideas off of her and make sure that what I'm doing is on exactly the right track. I'm also going to assume that we're in an enterprisey kind of shop, like a large shop that has some change control restrictions, and you don't want to wing it. You want to be fairly safe and confident of what you're doing. Like if I think that something's going to fix it, I'm going to go test it in dev first to make sure. So we're going to start with an easy scenario, the missing log backup. Penny and I get an email from Sam, the storage administrator, and Sam says, you know what, I was running out of drive space over on our backup share, and I was moving some things around just temporarily to free up space. I think I might have accidentally deleted one of your recent log file backups. Can you go in and just check and see if there's any way you can work your way around it? This is tricky for us as database administrators because we don't usually monitor the backup share. I'm lucky that Sam emailed us and told us what was going on. But most of us, when we do backups, we're writing to a share that we can also delete from. Because you probably have jobs that go in and delete files older than 3 or 4 days. Well, in most enterprise shops, you run into a different kind of security issue where you can write files to a share, but you can't delete them or change them. This is what you do for backup shares at large enterprises to make sure that people don't go behind you and screw around with the backups. We don't have that level of security here, and Sam did indeed accidentally trash one of my backups. To keep things really simple, I'm going to say I have this full backup and these 2 transaction log backups, and I'm missing log backup number 2. One way to do it would simply be to go take another full backup, because right now I can't restore to transaction log number 3 if I'm missing log file number 2. I can't get myself to a point in time that's current. One way to approach it would be to simply take a full backup. And when I talked about this in class once, I had a guy raise his hand. He goes, well, why wouldn't you just take a full backup? I said, well, in a lot of shops, you can't take a full backup in the middle of the day because it slows things down too much. He said, what are you talking about? All my shops, all my servers, they're all sized so that I can run a full backup or a check DB in the middle of the day and no one will even know. He said, doesn't every responsible DBA do that? I said, well, as it happens, we have like 30 of us in this class. Why don't we take a quick show of hands? How many of you could run a full backup in the middle of the day without anyone complaining about performance? No hands went up, not a single DBA. This DBA was shocked, and I said, well, and a couple of you are saying in questions and answers, no, I can't do that. So I turned to the DBA and I said, look, I've got great news for you. You have a great company who's buying you enough hardware that you're able to do that kind of thing. That also means that you probably shouldn't ever assume that anywhere else you go is going to be that luxurious. And I turned to the rest of the class and I said, let me also tell you guys have good news too, because this guy here might be hiring, and this sounds like it would be an awesome kind of place to go. For the rest of us, we don't have that kind of luxury. So one way that I can jump past a missing log backup is to go do a differential. Here because I'm an anal retentive DBA, I'm gonna go test it to make sure that this actually works. What I'm gonna go do is over on my development server, I'm gonna go restore last night's full backup. I'm gonna go restore the full backup, and I'm gonna use with no recovery so that I can continue to restore additional transaction log backups. And the first transaction log restore works fine. I'm able to restore TRN number 1 with no recovery. But because I'm missing number 2, if I try to leapfrog past it and take number 3, it doesn't work. If I look in more detail, SQL Server has these log sequence numbers, LSNs, and you can look across different backup files, across fulls, differentials, transaction logs, and see when their LSN started and when their LSN finished. Now, unfortunately, my LSNs don't match up here. I have this missing gap in for transaction log backup number 2. So here's how I'm going to work around it. I am going to go take a differential backup in production. This is the server where activity is still happening at. I'm going to go take that differential backup. People often don't do differential backups because often they do just fulls every night, and the differential is the list of changed data pages, and not just the list, it's the actual changed data pages since the last full. That differential backup is tied to the last full. I do need the most recent full backup in order to apply this differential, but it also is tied into LSNs. So now when I go in and I restore, I can restore this differential in dev over on top of the log file I already started restoring. The differential just applies whatever pages were changed past that LSN. So normally we think of when you're doing a restore, you're going to take the most recent full, the most recent diff, and all the logs since, but you can kind of intermingle these things. Now over in production, I'm going to go take another transaction log backup. We were at number 3. I'm going to go take number 4 in production. And now I'm going to go restore that over on dev, and it works. I can restore any transaction logs that are taken after that differential. Having this differential backup helps me leapfrog past any missing log backups that I had. Here in this case, I had every night I'm doing a full backup. Then I had a whole bunch of log files, but I was missing one. I'm able to jump right past it and then continue applying additional transaction logs. So normally when people think about doing restores, they think about getting to the most current point in time possible. People don't want to lose data if they can avoid it. And I can get to right now, but what if I need to get to a slightly earlier point in time? What if someone calls in and says, oh man, 5 minutes before you did that differential backup, we dropped a table. Can you get us to as close to point in time as that as possible? No. I can't restore to any point in time between when that missing log backup started, the LSNs that it was covering, all the way through till when my differential finished. So I do have a gap inside here. Even though I have log files, I can't restore the differential and then jump back 5 minutes. Differentials, I don't have a problem with them. They're neat, cool little tricks. They help you jump past those missing log backups. But whenever anyone says that they are doing differential backups, I just want to make sure that they have the full. I know a lot of shops where they say we take a full once a week and then we do differentials all week long. And then when we look at their backup scripts, they're deleting backup files that are older than, say, 48 hours. So on a Thursday, if you go look at the backup folder, there's only a couple of differentials in there and some log files. And the only way they're going to be able to do a restore is if they go back to tape to the full that was copied off to tape, meaning their recovery time objective, their downtime, suddenly takes more time. This is also why this chart starts to influence how much backup space I need. The quicker that we want to be able to restore to, the more I may need my own fast backup share, and I may not be able to rely on tools like Commvault or Data Domain if they're not able to restore fast enough. We've got to actually do restore tests. Client Tara was working with here recently had switched to one of those kinds of utilities that then couldn't restore as fast as the business had guaranteed. Whenever I'm missing log backups, this differential trick is a nice one-time trick. You just have to know about that missing log file backup in order to get this done. That's the other big problem that I have here. If someone's deleting my log backups, I may have a larger problem that I got to go troubleshoot. The next common problem that we run into is oops deletes. People hardly ever restore a whole database. What they really want to do is restore an object. They want to get a specific table where somebody did a fat-fingered delete or a fat-fingered oops. So as a common example, Penny and I get an email, and in the middle of a working period, somebody did a deployment. Our developers are started to do agile development. They're pushing to production more and more frequently. Well, someone did a push into production, and they deleted all the data in a table. But the tricky part is, as soon as they did the delete, they didn't call us. Stuff was still happening inside the database while they were freaking out and Googling SQL Server undelete or SQL Server undo or recycle bin. After they did the delete, more data continued to flow into the database. People are doing inserts into that table, and I need to get all of the data back as of when they did the delete. The business has said they need me to get as close as possible to that exact point in time. So looking at this, my SQL Server policy here, the business has said, what I want you to do is go restore this database under a different name and get the data out of there. Then go push it back into production if you can. The quicker you can do it, the better, but you just need to get right as close to as possible as when Bobby did that delete statement. This generally involves splitting up into teams. I'm going to have one person deal with the meetings and the yelling while the other person goes in and tries to do the restore. When I go in and look at my folder where all of my backups have been happening, to keep this really simple, I'm just doing a backup every 5 minutes, and I put all their names in order. So I have a full, and then I have 10 transaction log backups. And nobody knows exactly when it happened, just that it happened recently. When I go look at my critical table right now, all of the rows say after the oops. Now what I'm doing here is I'm making this demo as simple as I possibly can, but in real life, you would have an intermingled jumble of wacko data in here. What I'm looking for as I'm stepping through and doing the restore is I'm looking for a table full of data that says before the oops. I don't want to see an empty table, and I don't want to see after the oops. I want to see data in the table where it says before the oops. That will indicate that I've found exactly the right data. So let's see how it works. What I'm going to do is I'm going to start by restoring this database under a different name or under a different server, either way. And I'm going to restore it with NORECOVERY so that I can apply additional transaction log backups. I'm pretty doggone sure they didn't do it right after the full. I think it's going to happen later, somewhere in the transaction log chain. So the first thing that I'm going to do is I'm going to restore the first log. I guess this is the second thing that I'm going to do. I'm going to restore the first log, and I'm going to use with standby. With standby tells SQL Server the people are able to go in and query this database. I'm putting the database into a read-only mode. The standby file can be anywhere. You can put it on the SQL Server C drive where TempDB lives. The file name doesn't matter. You can call it MP4 if you want. Totally doesn't matter. Anything, it's just that this is where SQL Server is going to store its working area about which transactions it's rolled forward and which transactions it's rolled back. If you want to put it on fast storage, that's absolutely fine. That's the least of our problems right now. So after I've done this, after I've run the restore log with standby, Now I can go query the table. This is exactly like using log shipping with a standby database. I can now do a select star out of my table, and I get a whole bunch of data that says before the oops. Is this the right data? I don't have a way of knowing. People may have been adding more data through the course of the day, and the business has asked me to get as close as possible to when the delete happened. So what I have to do is I have to go restore the next log file, and the next log file, and the next log file. And you can imagine that this takes some time, especially when you have a whole lot of log files. In a perfect world, you might have been dumping this data into a temp table or into a user table in a different database every time you finished a log restore. After log restore number 1, you go insert the data into a table. After log restore number 2, you insert the data into a table. And when we get to log file number 8, dun dun dun, suddenly when we do the select star out of our table, there's nothing in it. Okay, so now I know I've gone too far. At this point, I know somewhere inside transaction log number 8 is when that delete happened. I can get a little bit more in terms of time detail by using the restore header only command. Restore header only will tell you when the previous backup started and finished, and when my backup, number 8, started and finished. So we know that 7 finished around 1454, and then backup file number 8 finished or started at 1459. We know that it happened somewhere inside this range, but we don't know exactly where. If I had a transaction log backup every minute, that would automatically get me closer. At least I'd know I was within 60 seconds. But right now, 5 minutes of data could be a big deal. This is where I might pop out to the business and just say, right now, I can get you the data as of 5 minutes before the oops, but things may have changed in the 5 minutes leading up to the oops. And if I want to get that data out, I can use the stop at command. Stop at with restores lets me put in a time in here and stop the transaction log backups at points along the way. I can restore at certain points and say, show me what it looked like at 1444 or 54, 55, 56. But unfortunately, because I've already restored transaction log number 8, I can't go backwards through transaction log number 8. So I have to restart this whole process again. That blows. This is horrible. But if business says we've got to get as close as possible to that oops, this is what it looks like. I'm going to restore through the full plus all the logs through number 7. And now I can start creeping through number 8 and say I could stop every second or every minute. But this is going to take forever. If the business tells you you need to get as close as possible to the oops, how big of a jump do you make? Do you go 1 millisecond, 50 milliseconds? And how long is that going to take that restore log to apply? When you've done this the first time, after you've gone through an actual oops recovery process, you go, you know what, man, there has to be a better way. And there is. There's an undocumented command called fndumpdblog. And whenever I say the phrase, there's an undocumented command, I immediately see people picking up their pens and writing like they want to take notes and go, oh, this is the answer. This is not the answer, but I need to show you just how bad this sucks. If you wanted to get closer, and I'll show you a better way to get closer, but if you wanted to get closer, fndumpdblog does have a problem. In unpatched versions of SQL Server, it burns up CPU schedulers and does not free them back up, or worker threads, burns up worker threads and does not free them back up. Here, I'm just going to run it against a dev server, so I don't really care. I'm going to jump back into the demo and show you how fndumpdblog works. That looks pretty intuitive, doesn't it? fndumpdblog lets you point at a transaction log backup and it will read the contents of the log. Now, when I read through that, it tells me here's the current LSN. We're stepping through all these log sequence numbers in the transaction log. Here's what was done, and here's the transaction ID. Now, you don't get who did it. You don't get the delete statement. You don't get any text in there because this thing is not optimized for human beings to read. The transaction log is optimized for SQL Server to write as quickly as possible. So even though I see deletes, I don't know what table is involved. I need to now join out to system tables to figure out which object I'm even deleting. I have to go look at allocation units, syspartitions, and sysobjects in order to see which pages or which objects are involved in the delete command. I'm going to say where the object's name is help me and the operation that I'm looking for is the delete rows. Of course, I'm explaining this casually, but this is something that's going to take you 15, 20, 30 minutes to do when you're under the gun trying to resuscitate these dead rows. So we're good. I do have data comes back, and I'm guessing, but I literally am only guessing, that when I see hundreds or thousands of rows that are all deleted by the same transaction on the same table, that this is probably the guilty party. It's a fair assumption to make. So I know that when I want to go do a restore, one of the cool things about the restore with stop at is it does take it takes times. There's also a stop before that'll say stop before a specific LSN. So I can march right up to a given log sequence number, but stop before that, right before some bozo does their delete. There's only one problem. The log sequence number that comes back from fndumpdb log is not the same log sequence number that SQL Server uses for the restore command. So going a little bit deeper into Google, our friend Robert Davis, who wrote the book on database mirroring, also wrote an undocumented, unsupported function to change fndumpdb logs LSNs over to the database engine's LSNs, which kind of tells you what Robert Davis's job was like if he had to do this so often that he had to write a function in order to pull this off. Now, when I take Robert Davis's function and pass it against fndumpdb log, now I finally get a converted LSN that I can actually use with the restore command to say, stop before this LSN number. Pausing for you to laugh. And at this point, you can finally do a select, getting all of the data out of there and pushing the data off somewhere else, like into another table where you're going to go do the processing. Whoops. Is this technically possible? Yes. Is it practically doable? No. When you're dealing at scale with a real production size database where lots of inserts, updates, and deletes are happening, all I've even done through the past of this discussion is tell you how to get the data right before the command. But imagine if you did this command, you're totally stressed out, and it wasn't a delete. It was an update. And you updated half of the rows or you updated half of the columns, and now you got to start joining things back together and taking locks and figuring out how you're going to get the data back to exactly the way that it was. These answers all suck. Everything with oops deletes is really ugly. So I want to step back and think about, when do oops happens? When does good data go bad? One way that it can happen is when you do DDL. If somebody goes in there and alters a table or drops a table, you can do DDL triggers so that whenever someone does a drop table or someone alters a table, adds columns, drop columns, you can capture the statement that they did. You don't necessarily get an undo script though, because if someone does an alter table and they drop a column, you can't just get that data back via their command. You're going to need the contents of the data first. And if you do a DDL trigger, you can't really copy the table every time someone does an alter. It would simply take too long. Your stuff would time out. DML, every time someone does an insert, update, or delete, this breaks stuff all the time. But how do you know what's a good update versus what's a bad update? Well, I know most of the time the way you can tell if it's a bad update is if it comes from SQL Server Management Studio, but that's a separate discussion. You can do things like change data capture. You can use triggers to log stuff into history tables. But this is all huge performance impacts against the SQL Server, and you may never have an oops delete. So you're incurring all of this performance penalty just on the possibility that something might happen. Instead, here's what you want to do. When the business says we can only lose so much data or be down for so much time, this is where you start looking at third-party tools. Lightspeed and Toad both have log readers where they can read the contents of the backup file. There is a gotcha. With Lightspeed and Toad, they can only read the contents of Lightspeed's backup files, not native's. So there's another third-party tool, Apex SQL Log Reader. This can read the contents of native backup files, but it's single-threaded. The next version of the senior DBA class that I do, I'll actually show you screenshots of a demo where I walk through with Apex SQL Log Reader, and it takes half an hour just to read a relatively small transaction log file from Stack Overflow that I just do as part of a demo, maxing out one core 100% CPU while this thing runs. I like both of these tools, but you need to understand how to use them and how you have to prepare ahead of time to be ready for using them. For example, if the business tells you you must handle oops deletes within a certain period of time, then you may have to be taking your backups with Lightspeed or Toad. There just may not be any other way. Or you have to put in some kind of transaction log or some kind of change data capture type feature. Or if the business says you've got to get within 60 seconds, but 60 seconds is good enough, then you just use transaction log backups every minute. That way you restore forward every minute, dumping that stuff into a table as you roll forward. Whenever you find the data that's no bueno, then you can simply use the last round of table inserts that you did. Whew. So those were two ugly scenarios. We covered our oops backups and our missing log file. Now let's tackle a relatively straightforward one. How to approach your slow backups. What do you do when you have a large data warehouse, and typically by that I mean a terabyte or larger, and the backups just aren't running fast enough? There's three common approaches to this. First, if you only have a couple of SQL servers that are having this problem, and they've got, say, a terabyte of data or less, just go buy a third-party backup tool. Whether it's Redgate's SQL Backup, Idera SQL Safe, or Quest Lightspeed, all three of them have roughly the same equivalent of functionality. All three of them cost roughly about $500 to $1,000 per server, and the difference that you're going to get in there is going to be better than the difference you could get spending a few days yourself trying to cobble something together to make it go quicker. I used to work for Quest years ago, six years ago now. And so it may sound like, well, he's just saying that as a vendor type guy. This is what I would do too if I only had a couple of SQL servers that I had to manage. With the second layer down, if you've got a whole bunch of terabytes of data on the SAN, if you think you have, say, 5, 10, 20 terabytes worth of data all together, then SAN snapshot backups are a really slick way to do it. We're going to talk about those tomorrow. They're really designed well if you have, say, 1 terabyte or more in a single database. They're not really good for a lot of smaller servers or even a lot of smaller databases, but they're great for 1 terabyte or more on a single database server in a single database. These things are going to make backups take, say, 5 to 10 seconds, no matter how large the database is. They come with plenty of gotchas. We'll talk about those tomorrow. And then on the third one, what if you need to make backups faster and you have a lot of SQL servers to manage, which probably deals with or corresponds to a lot of people in this class, in the senior DBA class. I bet a lot of us in here have, say, 25 to 100 database servers per person. Here, you may not want to spend third-party money across all of those servers. Instead, you can do manual tuning to make your backups go faster. There are actually ways that you can do manual tuning to make your backups faster with several cryptic parameters and performance tuning tweaks. The SQL Cat team wrote a white paper on how you go about doing this. This white paper is really old. It's like 10 years old, thinking in terms of 1 gig Ethernet cables. It even suggests tricks like putting together multiple network cards just to get enough bandwidth to push your data out as quickly as possible. These days, the network cable trick doesn't matter as much when you're on 10 gig Ethernet, but everything else in the white paper still is valuable. The classic example is if you back up across 4 files, if you stripe your backup across 4 BAK files at once, your backups will typically go 4 times faster. SQL Server has internal limitations about how much it'll write to 1 backup file at a time. I have seen instances where writing to 8 backup files was actually 8x faster. You do get a diminishing amount of returns though, especially based on where you're writing to, like whether or not the target is fast enough to keep up, and whether or not your network is fast enough to keep up. And of course, how fast your data files are, whether or not your data files are able to push the data out quickly. Doing this level of tuning will take, say, a week for you to understand the concepts that are involved, build a quick proof of concept rig, test your backups at different throughput settings. But once you've done that, you can apply some of what you've learned across lots of SQL servers fairly quickly. The advantage of using third-party tools is a lot of them include adaptive compression built in, like if they detect that the write target, wherever you're writing your backups to, is extremely slow and can't keep up, they will spend more time on compression so that they don't have to write as much to the target on the other side. You don't even have to turn that on. These tools just do that for you automatically. But of course, when you have 50 or 100, 200 SQL servers, that becomes less cost-effective. So out of what we talked about in this module, big thing with the senior DBA class is that minimal data loss is really hard. When the business tells us we can't afford to lose data and we can't afford to go down, sketching these problems out and doing thought exercises about how am I going to react to each of these and what's my current state, figuring out exactly how long you will be down when one of these things happen. This is our job as a senior DBA to fill out that current state column. Of course, the business says you can never lose data and you can never go down because they don't realize how far off we are right now. It's my job as a DBA to say, based on the infrastructure that I have, here's what I can meet. Then, if you want something better, here's what I'm going to sketch out in terms of a budget because I've already wrung all of the performance I can out of our existing backup and recovery solutions. Whenever I'm dealing with you can't lose data, I also want to ask questions to the business like, what happens if Bobby drops a table? Should I just recover that one table in isolation, or do we have things like foreign keys and cascading deletes that will make it harder for me to do that? Will I be able to lose changes that were made after Bobby's changes? For example, if Bobby trashes a table at 10:36 a.m., but doesn't tell me until 11 a.m., are we willing to just walk away from the customer data afterwards? If they say no, I have to come up with time numbers on how hard it would be for me to accomplish that. The business assumes that if you don't say anything, you're able to do these kinds of tasks. RPO and RTO really dictate everything about your backup strategy, your high availability and architecture. I even drive home to say to folks, when you're going to ask questions about your servers later after the senior DBA class, when you email stuff in, I ask for this. I want you to fill this out, both your current state and your goals, the business's goals, because this drives so much about the answers. People will often say, should I use an availability group or database mirroring? This is the key. How many days of backup history do I need to keep? This is the key. Knowing this and things like how often you're doing check DBs really influence your architecture design.